quadratic equations, which, if you took your PSATs yesterday, there were an awful lot of quadratic equations on the PSATs, weren't there? It's too bad we didn't do this unit beforehand, huh? Okay, we're going to graph these on our calculators. Okay, so the way we're going to do this, you go to your y equals button, okay? Go to your y equals, and we're going to put in, that's what this is, the y equals. Chase, can you please turn that down? So we're going to put in point, you don't need the 0, 0.25, so 0.25. And here's the x key, right there. See the x? Hit the x key, and then there's a squared key right there. So hit the squared key, and that's going to graph it for us. We're going to hit the graph button, and there's my 0.25 x squared. Okay. Now, we're going to have to sit here and graph that on our calculator, on our sheet. And the way we're going to do this is we're going to get some points. Okay, the way we get some points is, again, we're going to look at the table, which is that T-chart. Okay, so I'm going to hit the second key. Because that table's in blue, I need the second key, graph, and there's my table. For Algebra 1, we kind of, when we're beginning this, the parabola, it's called a parabola, it's U-shaped. We're going to, usually stick around 0, 0, okay? So we're going to put that point in there, 0, 0. Here, put it in the y equals 0.25 x squared. Here's my squared button. Okay, did you hit graph? And did you get this U shape is called a parabola? Oh, make sure you're on Zoom standard, okay? See how hers is a little off? It's because somebody was playing with the scale of the axis. So if this is happening to you, go to your Zoom key and hit the number 6 for standard. So hit number 6. You can either go down and highlight it, hit enter, or just hit the number 6 key. And it'll put it back to default. Okay? Okay. Now I'm going to go back to my table here, grab some points. So hit second graph, and I have the point 0, 0. And I have the point 1 and 0.25. I think I'll leave that one because I don't like decimals and fractions on a graph. I'm going to go to the next one. Okay, it says 2, 1. So here's 2, 1. It should be. It should not be. It should be exactly like mine. Let me see your y equals. Unless somebody was really messing around with your calculator. Nope. You got the same numbers. Yep. You just didn't go to the x equals 0. Okay. All right, so I got 2, 1. The next whole number here for y is 4, 4. So I'm going to put that on. 4, 4. Oops. 1, 2, 3, 4. 1, 2, 3, 4. Nope, that's it. You think I would learn by now. No, I get it. I didn't mess it up. Okay, and also I'm going to pick up some negative numbers. Again, I want to pick up some whole numbers. It's easier to grab. So I got negative 2, 1. Negative 2, 1. and negative 4 comma 4. Now I can actually, put a line through this. Again, it's called a parabola. Okay. Now, let's talk a little bit about this parabola. All right, first of all, the ends of this parabola go on forever and ever and ever. Okay. This point, now remember, I got these points off of a table, right? I had an XY table. I don't know if you guys remember being taught the T-chart back in pre-algebra. But our X, when I X, our X's are independent values, right? Or our inputs, and our Y's are dependent upon what we put on it, put in for X. So our X is our input, Y is our output. Independent values, dependent values. Those are the most common terms you'll hear for X and Y. So when we chose 0 for X, we got 0 for Y. When we chose 2 for X, we got 1 for Y. And when we chose 4 for X, we got 4 for Y. Same with the negatives. When we chose negative 2 for X, we got positive 1 for Y. When we chose negative 4 for X, we got positive 4 for Y. Now notice a couple of things about this T-chart. This point is what's called the vertex. That's, in this case, is the minimum point of our graph. Okay, it's the minimum point of this graph. Now, if my parabola was upside down, it would be a maximum point, be the highest point. But for this graph, it's the lowest point. The vertex happens to be a minimum. Here's another thing you should notice. Look at our y values after the vertex. They're the same, aren't they? You should get, well, you not should, you will get the same y values for every x that you choose on both sides of the vertex. Okay, so this is my vertex. For this problem, happens to be a minimum, and it's the point 0, 0. All right, let's go ahead and start putting these other ones in. Ready? Any questions so far? This is like really the meat and potatoes of Algebra 1. Graphing the graphs and factoring. Okay? That's what we'll probably be spending most of the rest of the year on. Really important concepts in Algebra 1. Ooh. What's up, Jonathan? Okay. So you're going to want to put in your y equals. Okay. And our problem was 0.25, 0.25. Here's my x key, x, and this was squared. Then we're going to graph it. That's the graph I got. And to help me make this accurate on my paper, I'm going to hit second graph, and it brings up this table values. Okay, it's this T chart here. See how I picked up 0, 0, -2 for X, it's +1 for Y. Okay, I use those points. 2 for X, 1 for Y. And then I think I used -4 for X, because those are whole numbers. They're easy. Okay. That's where I'm at so far. Okay? All right. The next one. Let's go to our, again, we have Y equals. We're going to go to our Y equals. For now, I want you guys to clear this out. And we're going to put this one in. Be careful here. You don't need the zero. You don't need the zero before the decimal point, but we do need that negative sign. Now, don't use the minus sign on your calculator. Okay? That means an operation of subtraction. You have to use this one for a negative sign on your calculator. So we're going to put in negative. See how my negative sign comes in? And then I'm going to put 0.5. So negative 0.5. Yeah, that came up negative 0.5. Then I need my x. My x is right there. So I'm going to hit the x key. And then I have to square it. I'm going to square it with the squared key right here. Okay, I'm going to double check. Negative 0.5x squared. Huh? Are we good? Negative 0.5 squared. Then you're going to graph it. This one happens to open up downwards, right? So let's go ahead and sketch this on our graph. We're going to need some points. Then I'm going to hit my second key and the graph key to get my table. And here's my points. Again, I know that this is the vertex because my values for y are the same afterwards. See how I got negative 0.5, negative 0.5, negative 2, negative 2. And again, I'm going to use my whole numbers. So I'm going to use 0, 0 for my vertex. Yes, ma'am. Huh? Yeah. I'm going to use 0, 0 for my vertex. And I'm going to skip the 0.5 because I don't like point decimals. I'm going to go to 2 comma negative 2. So 2 comma negative 2. Two comma negative 2, and my next whole number here is going to be 4 negative 8. So 1, 2, 3, 4, 1, 2, 3, 4, 5. So it's going to be somewhere down here. Okay. And then I'm going to go ahead and pick up some negative numbers for my x. Again, I'm going to use negative 2, negative 2. So negative 2, negative 2. And I should have negative 4, negative 8. Negative 4, negative 8, which is going to be negative 4, negative 8 down here. Okay, now I can sketch my graph. So there's half of my U, and here's the other half of my parabola. I'm going to label a couple of things. Let's see, this point is my vertex. This time it happens to be the highest point of my graph, so it's a maximum. Maximum. Again, it's at 0, 0. This one happens to open downward. So I'm gonna state, well, just state that somewhere. Let's see, opens downward. All right, ready to do the next one? Okay, C. Yes, it's not in my classroom. Unless I received a new student today. Okay, so C, we're going to go back to our y equals. I'm going to clear this out, hit clear. And I'm going to put in there 1. I don't even need the 1. But if you want to put in 1, it's fine. Then I'm going to put in the x, which is right here. And then I need the squared key, which is right here. Okay. Hit graph. And there's my graph of y equals 1x squared. I'm going to go ahead and graph it. So I need some points. I'm going to hit my second graph button, grab some points. Again, here's my vertex because my y's, I know that's the vertex because my y's start being the same afterwards. So 0, 0 is my vertex. Okay, I'm going to have 1, 1, 1, 1, 2, 4. I only need 5 points to make my parabola, and a very accurate one. Negative 1, 1, negative 1, 1, negative 2, 4, negative 2, 4. 1, 2, 3, 4. Actually, this should be 4. Okay. Here's my left side of my parabola. Right side of my parabola. Okay, a couple of things about this parabola. This one's actually kind of important. First of all, this is called my parent function or parent graph. Okay. Y equals x squared is the parent graph. Okay. You will need this later to know this because when we do transformations or start shifting our graphs, we're going to be comparing it to our parent function, our parent graph. Okay? So this is really an important equation here for parabolas. All right, a couple of things. Let's point out. Yes, ma'am. You mean after school? I think, no, I have a meeting. I'm sorry. Um, you know what? Let's work on it tomorrow in class. Can't come in tomorrow. Um, how about, so go back to our y equals, hit clear. Let's see, I need 2. Can put in the number 2. I need my x, and I need my squared, which is down here, right there, squared. Gonna graph this. There's my graph. I'm gonna get some numbers so I can sketch it accurately on my paper. Second key graph to get my table. I'm gonna find my vertex. So here's my vertex at 0, 0. Zero, zero. Let's see, 1, comma 2, 2, comma 8. It's going to be way off of here. And let's go the other way. Negative 1, comma 2, and negative 2, comma 8. Huh? I'm just plotting these points. Huh? But I like using 5 points. You could actually do it with 3. Okay? You don't need 5. You can do it with 3. I just like using 5 because I'm a terrible drawer and it makes it more accurate for me. Okay? I'm just getting those off of the table. Okay, a couple of things about this one. Let's see, my vertex is a minimum at 0, 0. Opens upward. And that's about it for now. All right, and the last one. Okay, I'm going to put in negative 5x squared in my y equals. So I got to go back to my y equals. I'm going to clear that out. So hit clear. Now I'm going to put in negative 5. And again, make sure you use the negative key, not the minus key. So negative 5x squared. Hit graph. Here's my graph of negative 5x squared. I need to plot some good points. Second graph. Find your vertex. There it is, 0, 0. All right, some numbers. 1, comma, negative 5. 1, comma, negative 5. And negative 20, I'm not even going to put on there. 2, negative 20, it's just way off. So I'm only going to have 3 points this time. Negative 1, negative 5. So here's my left side of my parabola. Here's my right side of my parabola. couple of things. See, this is my vertex. It's also a maximum this time, right? At 0, 0. This one opens downward, right? Opens down. Okay, does everybody have their graphs? All right, let's answer some of these questions. Okay, what property is common to all the graphs? What's the same with all of these graphs? Yeah, they all have a vertex at 0, 0. There's one. Sure. Okay, huh? They'll be fine. What else? What's their shape? They're all U-shaped. What do we call it? They're all parabolas. Parabolas. Anything that's the same for all 5 of them? Not the same, right? About it for all the same. All right, how about number G? Under letter G. Under what conditions does the graph of y equals ax squared, which is our parent graph, open upward? Okay, so let's look at the ones that open upward. This one opens upward. Yeah, they're all positive. Good. Which letter is specifically positive? The A. Okay, good. A is positive in all of the ones that open up. A is positive when opens upward. Okay, good. What about the ones that open down? It's negative. A is negative. I should put an A in my parent function. Up here, this should be ax squared. Okay, what about H? As the absolute value of A increases. Now, what's the absolute value mean? If I have the absolute value of a number, that means it comes out positive, right? So it's the absolute value or the positive value. What do we use a positive value for in mathematics mostly? For those of you who are taking geometry, positive value of any number is the distance, right? Distance. A lot of you use positive values of like even negative numbers for distance. Yeah. For like, finding the midpoints and the distance formula. You're all using pretty much absolute values for distance. Okay, so as the absolute value of A increases, so we're looking at A. We're not looking at the negative numbers anymore because they're all going to be positive. What's 0.25? That's a quarter, right? So this is actually my A equals 1/4 or 0.25. My A equals what in this one? 0.5 is 1/2. My A equals what in this one? 1. My A equals 2. And my A equals 5. So it looks like we're going from small, little bigger, double, a lot bigger. Okay. So as my absolute value of A increases, so as my A increases, what happens to my parabola? Get smaller, get skinnier, right? Skinnier. So it gets skinnier. What? Get skinnier, or we're gonna call that. Oh yeah, Jonte, Jonte, you should leave. Okay, get to your next class. Or in mathematics, we call that stretching, and we'll stop here. Stretches, stretching, stretches. All right, don't lose these. Please don't lose these. A lot of notes we took today.